Hello, everybody. This is Aaron Schwartz, one of the secondary mathematics specialists with Montgomery County Public Schools. Today, we're looking at a video called Fast Food, Faster Communications, and it's about expressions as a symbolic language. Now, this is in line with serving up symbols in the C 2.0 Algebra 1 curriculum. And if you have not looked at the checker border video, you probably want to view that first, because this is going to extend on the concept of algebraic expressions as a symbol or as an expression of a concept or a pattern. And those groundwork skills in that first video are critical for teachers and students. So in Unit 1, Topic 1, students learn to write and use expressions to communicate observed patterns. The key ideas include that algebraic expressions communicate meaning in context. So the idea is that you could use an expression to actually convey an idea. One of the helpful skills that students have is that they've been rewriting an expression in different forms and can shed light on how quantities are related. This is part of the 7th grade standards in Math 7 and IM, and it's also touched on in the checker border lesson, that writing the expression in a certain way helps explain the visualization that we have of a particular scenario. So we're going to talk about fast food, faster communication. And the C 2.0 Algebra 1 includes a sequence of lessons about algebraic expressions as a means of communicating meaning. So this comes up in checker borders, serving up symbols, examining units. But one of the ways that students can really connect to this idea of an expression serving a purpose other than calculating, serving a purpose of communication, is actually examining this clip from Mad TV. And I'm going to play part of the clip, but the whole clip is available on YouTube.
Hi, welcome to Burger Nation. How may I help you today?
Let me get 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on them, 4 more hamburgers with everything, a cheeseburger with no pickles, and cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one, everything but pickles, mustard, and tomatoes on the other, 3 large fries, 6 medium fries, 1 large fry, a junior fry, and 2 junior fries, 3 more cheeseburgers with extra cheese and bacon, 2 more junior fries, a hamburger with everything, 2 more hamburgers with everything, and 2 more hamburgers with everything, 4 large Cokes and large Sprite, 2 large Cokes and a small Sprite, 5 large Cokes and 1 large Coke and a small Coke, 3 small Cokes and a small Coke and a small Coke.
Okay, will that be everything?
Yes.
Gotcha. That's 2 hamburgers with just pickles, 2 cheeseburgers with another cheeseburger, everything on it, 4 more hamburgers with everything, a cheeseburger with no pickles, and a cheeseburger with nothing but pickles, 2 more hamburgers with everything but onions on one.
So as we can see in the video, the problem is that there's a communication issue. And this is where we would want to show the video and we would ask students, how could they have made this easier? And students may come up with, oh, maybe he should have had the order written down, or maybe he should have had symbols to indicate what he wants. And that's where you want to go. Okay, how do you use these symbols? What symbols do we need? How do those symbols help us? How do we distinguish between a cheeseburger and just a regular hamburger? And that's where maybe subscripts come in. And so this idea of building expressions as a way of communicating is really helpful. So for example, 3B might indicate 3 burgers. And we can do 3F to indicate 3 fries, or 3F subscript L to indicate 3 large fries. And that's where we would want students to start coming up with a way to communicate this order very quickly and very efficiently. And so with that in mind, what we really want to do is we want to start showing them this list of symbols for the serving up symbols lessons. And so we have this huge list, and now we want to frame it as, how does this help us communicate? Instead of being this overwhelming list, we might trim it down a little bit for the first day, or we may give it to them in full and say we're only going to focus on certain things. And so we can start to ask students questions to help them develop their understanding. Like, what is the value in having a list of symbols? And again, that goes back to the efficiency of communicating things. It makes it a lot easier to write, and it makes it a lot easier to read if you can look at one letter and know a full sentence. And how can we use those symbols to communicate efficiently? Again, it's about cutting down the time it takes to digest this information. If we know that 3C, we know that we've got 3 times the number of classes per lunch period. Again, streamlining that communication. And what might these expressions or equations communicate? And I'm about to reveal a few. So we might ask them, what is S plus 200? And now they need to look at their chart and say, well, S is the number of students that buy lunch in the cafeteria each day. So S plus 200 would mean 200 more than the number of students who are buying lunch in the cafeteria. All of a sudden, that expression has a meaning. It's not a calculation tool. How about G equals B plus 1? Well, we know that G is the number of girls that buy lunch each day, and B is the number of boys that buy lunch each day. So now we're actually saying that the number of girls who buy lunch is always one more than the number of boys who buy lunch. And so now the equation has a meaning. It's actually telling us values in relation to each other. Or how about F over S? Well, F is the number of food servers in the cafeteria. S is the number of students that buy lunch in the cafeteria each day. So now we have a ratio. It's the ratio of food servers to students buying lunch. And so now all of these expressions have a distinct meaning. They communicate an idea as opposed to just calculating a value. And this becomes the basis for how we can explore expressions, whether they're linear, exponential, or quadratic. And we can use this throughout the entire Algebra 1 curriculum. So questions for students. What might these expressions or equations communicate? Well, 2 times S. What's 2 times S? Well, it's double the number of students that buy lunch in the cafeteria. F equals B plus G over 50. Well, we know that F is the number of food servers in the cafeteria, and we know that B plus G is the number of boys who buy lunch and the number of girls who buy lunch. So now the food servers are equal to the ratio of boys and girls to 50. So when we take the number of boys and girls and divide by 50, we have the number of food servers we're going to use. And so it's a ratio. It means something. It gives us the proportionality. Or how about 3 times the quantity C plus 4? Well, we're talking about the number of class periods per lunch increased by 4 and then 3 times that total amount. And students can talk about what those mean. Now let's talk about what equations or expressions students can make and what are their meanings. And so we can ask students to develop their own expressions and to explain what they mean and what their purpose is and what those expressions communicate. So some questions for students. One of the things that we might want to do with this is expand it out to build expressions outside of the serving up symbols context. So let's talk about a scenario. This is a typical kind of assessment item. Instead of eating at the cafeteria, a few teachers decide to order pizza. The math teachers order P number of pizzas. We don't know how many they are, but we know it's being represented by the expression or variable P. So now we can ask students to build some expressions based on that. The PE teachers are trying to maintain a healthy diet, so they order 2 fewer pizzas than the math teachers. Write an expression for the PE teachers in terms of P, in terms of that math department. Well, if it's 2 fewer, they want 2 less than P, or P minus 2. This is really interesting. Now this expression has a meaning. It's not just calculate this. Now let's we're going to expand on it, and the English teachers are hungry and decide to triple the order of the PE teachers. Write an expression for the English teachers in terms of P. So we really just want to triple whatever the PE teachers had. So we're just going to triple it. We're going to say 3 times whatever the English teachers had. And we don't have to simplify it because this absolutely shows tripling the PE teacher's order. And it is enough to be there because now students are building expressions and they're using coefficients and constants to explain what their expression means. I hope that this video helps teachers create classrooms where students explore math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below.